This is a demonstration of a priori's web-hosted cost insight design tool. The first thing I'm going to do is click the link that takes me to the a priori tool, and then I'll log in. Once I do that, we'll be able to see some parts that I've already costed. What I'd like to do is cost a new component. So I'm going to go out and grab a CAD file from my system and drop it in. We're CAD independent, so we can read any type of CAD file and also extract product manufacturing information or PMI data from those files. Once the file comes into a priori, I have to answer a few basic questions, and then a priori will generate a cost. First of all, what's the process group? In this case, it's going to be stock machining. I'm going to manufacture it in the USA. I'd like to choose a secondary process. Perhaps I want to anodize it, something like that. So I'll go pick that from my list. Here you can see we've grabbed a type 1 anodization. And then maybe I'd also like to do a cleaning process on this thing. So I click that as well. I want to make 100 of these over 5 years. I can choose a material from my database or pull it from the CAD file. In this case, I've got aluminum 6061, and then I hit cost. It'll go out and send this for processing and come back with an answer in a few moments. A priori's now come back with a cost. Here you can see under material utilization, it's going to give me some details about the material, the density, what the rough mass was, the finished mass, the material utilization. If I want to change the material at this point, I can. If I go into design guidance, here we can see that there's been no failures, but if I take a look at the guidance, any machining issues, it's noticed 5. I've got some sharp corners down here, which I might want to clean up in the CAD model. I've got some side mill length to diameter ratio issues over here. So it's saying that I got a long skinny end mill in here. Then it's telling me that there were some holes that had to be reamed, some finish boring that had to happen on there as well, and then some slow machining operations. These things had to be ball milled. If I go in further investigation, it'll show me all my different hole and fillet sizes, standard, non-standard holes, how many machining setups, where the cycle time was, and where there's high cycle time areas in the part. So this area in here and this over here, this is saying that these surfaces all were milled with the side of the tool, and that's the length to diameter ratio of those end mills. If I go into tolerances, it said it's pulled quite a few tolerances, 56, some circularity, parallelism, so it has pulled those tolerances from the model. If we drop down a little bit further, we can go into the details about the processes that were selected, the cycle times. So in this case, I've got a bandsaw, which was 3% of the time, the 4-axis mill, it'll show me the machine it's select. Then I've got a drill press, I've got a jig board because this was a real tight tolerance in here, a grinder on the top surface, mask and bench, anodizing. So you get a full breakdown. That's by cycle time. This is by fully burdened cost on each one of those areas. If I drop down a little further, I can go into the costing result details and get more information on how much was spent on material, labor, overhead, and looked at that in terms of piece part cost, fully burdened cost, or total capital investment. Again, the full cost for this part was $593. And then finally, if I want to go in and address those issues on the bottom of the part, I can do that as well. So here I've got a sharp corner. What I'm going to do is go to the CAD file, make a change to that CAD file, simply add a round, and then save this model. And then we'll minimize the CAD, and then I can go under Actions and hit Update the CAD model. Now I can go into my database and choose that latest CAD model and then recost the part. A priori's now come back with the latest CAD model. Here we can see that that sharp corner is gone. If we go to Design Guidance, it'll also tell me that there's no longer any sharp corner issues, just side mill length to diameter issues. That concludes the demonstration.